What's your final R? 94. So it's not the same as your हम लोग. So at least जो values हमारे थे, it should come close to those values. Okay? You have trained as well. क्या हो रहा है? तो समझ में नहीं आया तो बुलाया क्यों नहीं मुझे? So you have to write your own code now. So let me explain this to you. Sit. So, so this is what we have. We have a P and R matrix, right? It has got certain values. See, 4 column ही बनाते हैं. 0, 2, नहीं एक value देना पड़ेगा. 0, 0. Okay, so we can assume this as ये each user का feedback है. और each column पर उन्होंने किसी एक मूवी का feedback लिखा है. Let's take movie या होटल ले चलते हैं. तो हमारा पहले यूजर ने फर्स्ट मूवी को 5 स्टार दिया, दूसरी मूवी को 3 स्टार दिया. बाकी 2 मूवीज उसने देखी ही नहीं है. He hasn't seen that, so he doesn't know. Our job, and same with every user. So our job is to figure out what might have he given had he been seeing this. Okay? To do that, what we do is that we try to find 2 matrix P and Q whose dot product is similar to R with these values. Okay, so we need to find 2 smaller matrix. This is what we call as matrix factorization. अब क्या करेंगे हम कि हमें तो पता नहीं है, but what we do know is this is 5 by 4 matrix. Okay, so if it's a dot product, what should be the size of P? 5 by something, and Q should be something by 4. Then the end product will be 5 by 4. Okay, so we start with a random P and a random Q. कुछ random values डाल देते हैं. So now अब हम now in P और Q को multiply करेंगे तो we'll get that error function Eij है. Okay, at every value. Okay, at every value point we will get an error function. तो E निकलेगा हमारा, और मैं उसके बाद आपको एक फंक्शन दे रहा हूँ कि मेरा अपडेटेड P और अपडेटेड Q क्या होना चाहिए. आपने E कैलकुलेट किया, एक अल्फा और बीटा कांस्टेंट है, दोनों को छोटा वैल्यू रखिए. समथिंग लाइक अल्फा इज 0.002, बीटा इज 0.02 और 0.02, राइट. इन 2 छोटे वैल्यूज के साथ हम इसको अपडेट करेंगे. फिर अपडेट किया हमने तो एक नया P डैश Q डैश आया, राइट. फिर इसका एरर कैलकुलेट करेंगे. विल कीप ऑन अपडेटिंग दिस टिल वी आर सेटिस्फाइड कि हमारा एरर कम हो गया है. Okay, so maybe run it for 100 iterations and see what happens. Okay, so कौन सा पेपर उठाए हो, गूगल वाला कि अच्छा शुगर देख रहे हो? क्या जो हमारा पांडास था वो नहीं कर रहा था, तो पांडास के लिए पायरेट स्टार सीखे. हाँ, पांडास नॉर्मली एसपीएसएस नहीं यूज करता. तो इसलिए ले लिया. तो बट उसमें तो 454 column data is very huge. So, but all of that is not data actually. Some of this is added. So gesamt means total. Okay. Right? So some of this is multiple columns added as well. We have to translate into English. So I don't know the meaning of it. So gesamt is total. That's about it. Okay. So आप अगर देखो, so duration, time, motivation, trend, sugar, 1, trend, sugar, zucker is sugar. Right? Uske baad, there should be something about women or men. And then you have got data with regards to what is the satisfaction total, acceptance total. And अगर आप पेपर पढ़ेंगे कहाँ है? We have to convert this LCV to PDF or LCSV to. Not necessarily can offer. हाँ, it will be good to analyze. It was easy for me, na? It will be easy. True, true. Have you got the paper with you? So if you read this, this is why मैंने इस presentation नहीं दिया है इसलिए आपको. So this is what that's their model is. So they are looking for किसी 3 तरह के motivator हो सकते हैं. There could be monetary motivator कि आपको पैसे दे रहे हैं भैया. There could be health motivation कि आपका health इससे सुधरेगा. Or there is no motivation. Right? कुछ भी करो हमें फर्क नहीं पड़ने वाला. हम खरीदेंगे. Right? The other factor could be gender. So they looked at the gender factor. So these are the independent variable. The dependent variable was the degree of self-regulation. कितना आप regulate कर सकते हो अपने आप को. Okay, and then they tested some social science hypothesis based on that. And these are very early results presented here. Essentially saying, this is out. Okay, this is out paper. It's an early studies from this thing, but we have the data set if you can extract any other meaningful information here. And that's why she gave me. हमने जो कहा था हमने बस early statistical analysis किया था, and all they did was look that. I mean, monetary motivation acts differently for men and women. Health motivation works differently for men and women, and so does no motivation. Okay. So they did basic order statistic, basic ANOVA analysis, and she wanted to see if we can use any sort of machine learning to extract a better information from this data. So once you read this paper, it will. अगर नहीं बना रहा है, then come and talk to me and I will explain what each line is. I will definitely read this. It's only 3 or 4 pages. So भले 9 पन्ना लंबा लग रहा है, आधे पन्ने तो references हैं. This is. मैं पढ़ लूँगा इसको पूरे. तो मैं एक बार डाटा को भी analyze कर लूँगा. CSV फाइल में करूँगा उसको. Okay. So the data has been lying with me. I never got time to work on it. So अब आप लोग देखिए. आप लोग का क्या चल रहा है भाई? आप लोग पीछे छुपे हो, मैं देख नहीं पा रहा हूँ आप लोग को. आप चीनी पर चले गए. Good. What about the code? Matrix factorization. Start कीजिए. आज नहीं तो कब? अगर start नहीं हो रहा है तो tell me, I will sit with you and start it. Okay? What about you? Are you writing matrix factorization or not? Okay. Mm-hmm. क्या correlation कर रहे हैं इन दोनों के बीच में? Might be interesting to see if Goldman Sachs has a correlation with आप किससे कर रहे हैं? The Standard and Poor Index. So SP index generally 500 shares को लेके चलता है. Right? It reflects how the market performs. So Goldman Sachs is one bank. So there may be. किस लिए कर रहे हैं आप ये? पहली बार सवाल ही मैं ये पूछूंगा. नहीं. The idea was I wanted people to create me a simple module for matrix factorization. No. So अगर आपको हम sparse matrix दे रहे हैं, and I want you to do matrix factorization to give me a filled matrix. So the idea is very simple. Half filled matrix factorization किए कि नहीं आप लोग कोर्स में यहाँ पर? नहीं किए, that's fine. भूल गए. But नहीं, standard में ये नहीं होता है. So essentially it's a sparse matrix हमारे पास दिया हुआ है. It has got some rows and columns. Number of rows and columns are 0. Okay. Can I write somewhere? Pen and paper. पुराने स्टाइल के. So the idea is this. अगर आप नहीं कर रहे हो तो that's fine. So there is a matrix like नहीं जितना भी कॉलम दीजिए that's your call.
Of any of the dimensions.
Let's take 5.
Require it to be a square matrix.
No. It's rather if it's not a square matrix is better.
Okay.
And the whole idea is that each row here represents the feedback from a customer.
Okay.
Each column here represents a product. Could be a movie, could be a hotel. The first customer ने हमें first product को 1 star दिया, 2 इन्होंने rating नहीं दी है. And our aim is to figure out what might have been their ratings. Okay? So we have to fill this matrix.
Okay, based upon the other feedbacks we have to.
No, there's no other information here. That's the only thing which we have. Okay? So this is matrix factorization. So what we do is we go and say, okay, let's try to find a PQ matrix. Okay? Of the known elements which are there, we can, and let's start with a random matrix. So P has to be, this is 5 by 4, right? So P has to be 5 into something and this has to be something into 4. Agreed? और इसको हम randomly start करते हैं. Okay? तो अगर हमने randomly start किया, तो the dot product will give me an error.
Yes.
Right?
The first order.
Yeah. So I've got an error function. Okay. I use that error function to update my element. So it's a gradient descent.
Through that error function. Okay.
So gradient descent हम plan करेंगे. हम keep on update करेंगे. After some iterations, I should get a matrix where these numbers look like this. This number looks something else. That something else will tell me what this person might have done.
Okay, so the thrown error will give that number.
आइए देखिए. Yep. So it's a classic thing. If you ask students to fill part of the code, it's very easily done. But if you ask to write a code from scratch, it takes more time. 100 iteration में आ रहा है? Good. So a girl has laid claim to the chocolate.
जैसे कि वो 0301 था ना,
हाँ.
0 की जगह 3 है, 3 की जगह 2.16 है, और ये 0 की जगह
So आपका alpha क्या है?
0.01.
Make it even lower. So essentially, look what has happened. Your matrix was trying to find the minima, but it has moved beyond minima. तो आपने बड़े step sizes से इसको move किया. So let's move it to smaller step sizes. Beta क्या है?
सर अभी पहले ही इक्वेशन को
Oh, आपने सिर्फ alpha use किया है. Okay. One of the reasons might be, let's try a smaller alpha. But beta introduce करना ज़्यादा मुश्किल काम नहीं है. Right?
यहीं पे
Let's see what happens.
सर इस ओरिजिनल रेटिंग में फ्लक्चुएशन ज़्यादा आ जा रहा है. 0 तो पास आ रहा है, ये ओरिजिनल.
Okay, so put beta. Let's see. Sorry. See, उन्हें गर्मी लग रही है और मैं जैकेट में परेशान हो रहा हूँ. So, if you are willing to work with the sugar data, नहीं AC ऑन करोगे फिर ये लोग भाग जाएंगे. आप लोग क्या जैकेट स्वेटर सब कुछ पहने हो? लॉ ऑफ हीट पढ़ा है ना? So if one room where you have got different temperature zones, in due course of time it will. Okay. आप ऑनलाइन कर रहे हो? इतना आसान होता तो मैं भी किसी वीकेंड में कर दिया होता, right? It's not very tricky either, but it's just a larger data set than anyone which we have played with. So there's two ways we can do things. If you're very stuck, I can show you a glimpse of how the code will look. Another trick हम लोग अक्सर use करते हैं, you'll be see a code for exactly 5 minutes without the ability to take pictures, and then you try to see if you can code it. No? Okay, let me see if I can do that. Okay, let's do this thing. Let me give you half of the code. Okay? And then you can fill in the rest of the half. There are some additional section to let the code converge. So you have my training dot. So how do I share this? Let's create another short URL. So you can see this. Okay. So that particular piece of code, and you can copy, has got everything except the error function and the update function. Okay. So you should be able to copy it and then work on it. Ignore the torch code. That is for a later. So if you are on this page, so everything except the error function, if you look here on the screen, you should have access to this Colab. So the error function is not provided. And neither are the updated values of pi, k, and q, kj. Okay. So that should make life easier. You want the short URL? Should I make it bigger? How is it going on? Working. Okay. उससे एक जगह बैठा नहीं जाता है. क्या कम आ रहा है? अब डेविएशन कम है. ओके. आपके अपने कोड में या फिर मेरे कोड? गुड गुड गुड. Let me see. So there was a reason I did not make you do the bland simple matrix factorization. Okay, that. Look. Is it approximately the same? So the numbers जहाँ पर पहले से numbers थे, there it is same. Where you had zeros, is it still having zeros or is it having a different number?
Different numbers. It's approximately 0.9.
So 0.9 is almost 1, right? We can, okay, let's stay. Wait, is it 0.9 or 0.9 something, something, something?
0.9 to another.
So it's 0.08 in 1. So it's about 8% error. Okay? Fine, it's not bad. But the question is where we had 0 in the original matrix. So what is the first column, row? Let's see. Did you have a 0 in the first row originally?
0, yeah.
Third column, right?
We got it was 0 in the third column,
Huh.
but we got 4.
So,
And in the fourth column, we got 0.96.
but originally we had 1.
Yeah.
So it's not bad. It's 4% error, right? So ऐसे मत देखो, आपका 1 चाहिए था, आपको 0.96 आ रहा है, तो कितना परसेंट एरर हुआ? Percent. 0.04 is the absolute error, but it's 0.04 in 1. तो error percentage कितना हुआ? Point 0.04 divided by 1 multiplied by 100. 0.04 है, 4%. 40% अगर error होता 1 से, तो would have got 0.6. Yeah. So if it predicted 0.6, my error would have been 40%. It predicted 0.96. So error is 4%. 4% error I can live with. But the interesting thing is not that. The interesting thing is what are we thinking of this matrix to be? The first row is the feedback from one customer. So if the first customer gave me 5 star, 3 star, and another 1 star, if he bought the third product as well, he or she would have given it 4 star rating. Right? So now it's telling me, okay, hey, look, to the first customer, I should suggest him or her to buy 4. I mean, if we assume 2.5 to be the boundary, 2.5 के ऊपर पसंद करेंगे, 2.5 के नीचे पसंद नहीं करेंगे. So now you had loads of 0 in your original matrix. अब आप बताओ कि हम किस कस्टमर को क्या रेकमेंड करेंगे? फर्स्ट वाले को रेकमेंड करेंगे थर्ड मूवी? सेकेंड वाले का कहाँ 0 था?
Second and third column.
Okay, so what will he?
In that we got 3.0
Mm-hmm.
and 4.05.
Oh, okay. So उसको भी हम कहेंगे भैया आप भी दोनों मूवी देख लो. What about the third one?
Third we got 10 in third column. That we got 6.03.
6.03. Okay, so is this the maximum value more than 5?
Yeah.
What's the maximum value here? Original matrix का maximum value क्या है? 5 है. Okay, fine. It gave a very good. So did it say something which nobody should watch? कि सारे में positive values इसने दिए हैं. So if you started with 0, did it at some point come to something less than 2.5 या सारे zeros को 4 पर ले जा रहा है? So first 0 जो first row में है.
Zeros को 0.1 तक लेकर 0.99.
Okay, so let's look at the one for fourth customer, right? Originally it was 1004.
At 10 we got 5.02 and in another one we got 1.06.
So, no, not the fifth. You're looking at the fifth customer. I'm looking at the fourth customer. The fourth row. So what was your original?
1004.
So 1004, right?
That was original.
That was original. What did we get?
First 0.99.
That's okay.
Then 1.06 at the place of 1.
Mm-hmm.
Then 5.02.
Okay, maybe she has got a slightly different number. But look for this way. If there was the second column was one movie, it is saying that this customer would have not liked that movie. So there's a choice between second movie and third movie. Which one we should recommend to the customer? The third movie. Okay. So that gives us one idea of how we can make a recommender system. ठीक है? Oh, good. You have got tons of numbers to play with. Right. Has everyone got their matrix factorization working? So you guys have got it. What's the status of you guys? It's not working? So let me come and have a quick look. We can solve it using, so this time we have used a gradient descent. There's also a regression based or OLS based method we can do. And then you can ask, there are already a large number of such problems solved, Netflix problem being that, right? Why can't we use their database and train a neural network to do it? It will give a slightly better fit, be quicker, because gradient descent is slow, sometimes does not reach the minimum optima, right? Depending upon the size of the step size you have given, it could jump or could overfit. Okay. Control, better optimize this. And the size. आपका size अभी बहुत ही छोटा है. Okay. So the model could then be used to, so the first work where this happened was, I think, in 96 or 97, when Google came up with a wide neural network and a deep neural network, a combination of a wide neural network, and it's a wide neural network was just one layer but many wide columns, and plus a deep neural network, and you add both of these two to do matrix factorization easy. And after that, there have been many papers on purely deep neural network or different approaches to do it in a different way. Actually, it's not just matrix factorization, it's a recommender system, how to build a recommender systems best using these things. Okay, let me look at these guys. क्या हो रहा है जनता? Sorry for removing your bag. अगले जन्म में पाप मिलेगा.
So change करना है EI and PI क्यों है?
No, but they are not to be constant. क्या है हमारा EI?
Error.
Error function. How do we calculate the error function? अगर आप constant दे दोगे तो हमेशा constant error होगा. तो हम हर iteration में क्या कर रहे हैं? We are coming with a new value of P and Q. Suggest भी कर रहा है cheater Google.
नहीं सब
नहीं, Google suggest कर रहा है basically. Right? So that, what does that say? My current Rij minus the dot product of Pik and Qij. Okay? So that's the error. अभी जो हमारा matrix है, okay? So the original matrix जो था, हमारा P and Q अभी predicted matrix है. The original matrix minus my P and Q matrix. Okay? Oh. And then हम क्या करते हैं? We create new values of Pik. We take the original value of Pik. Alpha हमारा gradient बता रहा है कितनी जल्दी हम converge करेंगे, right? तो we take the original value of alpha plus 2 times error times Qk, हमने जो equation derive किया था समझे, and plus एक beta value which is another from the same value. And same we do for Q. So हम essentially हर iteration में P और Q को update कर रहे हैं. हमने P और Q update किया तो अगले iteration में error update हो जाएगा. और हम करना क्या चाह रहे हैं? हम ओवरऑल एरर को घटाना चाह रहे हैं. तो हम ये कह रहे हैं कि जो एरर, एसेंशियली कहना ये है कि अगर हमारा एरर पॉजिटिव है, बड़ा एरर है, तो P और Q को छोटा करो. एरर छोटा है तो P और Q को बड़ा करो. और यही छोटा बड़ा करते 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 ऐसी चीज में पहुंच जाओ जहां पर आपको ये हो जाए. So let's see how does this work. Actually, you know what? Okay, you have given a काम कर रहा है कि नहीं? So now let's compare this to our original matrix. So 3 था, हमने 2.97 आया. 0 की जगह 2.23 आया. So we can think of it like this way. So each row represents the feedback of a customer. So पहले customer और each column represent a product. एक मूवी रिकमेंड कर देते हैं. तो पहली मूवी को हमारे पहले कस्टमर ने 3 स्टार दिया और आखिरी मूवी को 1 स्टार दिया, और दूसरी और तीसरी मूवी को उसने देखा ही नहीं है. अब हमें डिसाइड करना है कि उनको रेकमेंड करें कि नहीं करें. हमें तो पता ही नहीं उनको अच्छी लगेगी या नहीं लगेगी. Right? Now, this factor says, after doing this whole, my first number comes 2.97, which is close to 3. Last number is 0.99, which is close to 1. If you look at these two numbers, एक में उसको 2.23 दे रहा है, दूसरे में 0.04 दे रहा है. Considering my maximum number goes up to, well, 9, that's a little bit high, but if you pick a threshold, say 2.5, so 2.5 से नीचे अगर मेरा prediction है, और या 2 से नीचे prediction, then most probably a customer movie like नहीं करेगा. So going by this strategy, this customer will not like the third movie. He may like the second movie. तो अगर हमारे पास 2 ही प्रोडक्ट हैं, 2 वो खरीद चुके हैं, तो हम ये वाला रेकमेंड करें उनको कि सर आप शायद ट्राई कीजिए. राइट. सेम फॉर द थर्ड कस्टमर. थर्ड कस्टमर को शायद पहली मूवी अच्छी लगेगी, एंड अगेन थर्ड मूवी अच्छी नहीं लगेगी. एंड यू सी वन ऑफ द रीजंस व्हाई दिस मैट्रिक्स हैज डन दिस वे, कि थर्ड कॉलम बहुत लोगों ने देखा ही नहीं है. राइट. अच्छा, दैट्स अ वेरी गुड. मैं अभी बात करूंगा. तो थर्ड मूवी वो किसी ने नहीं देखा, हमें नहीं पता किसको अच्छी लगेगी वो. ओके, लेट्स डील विद दिस नंबर हियर. आर यू डन? कैसा चल रहा है?
Still figuring it out.
So let's think of this as a matrix factorization issue, people. So let's try to understand the meaning of this a bit. So I've gone and talked to each one of you individually that we wanted to see this as this matrix represent ratings given by a customer for different products. So we can think of each row as a customer and each column as a product or a movie or a hotel. So my first customer has given 3 star to the first product, 1 star to the second product. And there is a very, by chance, the third product has only been seen by 1 customer. Okay? Who, by the way, only likes this and does not like the other 2. So it is a very difficult matrix, so any result. Now we have got after doing all of this is a value like this. Okay? Now we can think of it in this fashion. So we're trying to make a recommender system. Now we know our first customer has bought the first product at the last product and gave it a 3-star and 1-star. 3-star, let's assume that a good number. Anything above this, the maximum rating is here is 4. So let's assume anything above 2 is good, anything above 2 is bad. So he or she liked the first product, did not like the last product. Now we have 2 more products to offer. Which one should we offer to this customer, or should we offer both? So going by these numbers, it believes or it thinks the customer may like the third product. It has 2.71. Will certainly not like the second product, is 0.06. And one theory which you can see here, so the only customer who has seen the third product is the last customer. Okay? Who has not seen the first product, has seen the second product which has not been seen by the first customer either, but has seen the last product and has given a rating which is close to the first customer. Okay, so one assumes that the rating given to the third product or तीसरी movie को compared to the will be similar to this customer. Okay, and subsequently gone. So in this, if this was true, we could try recommending this product to the first customer. Bhaiya, watch the movie number 3. You may or may not like it, but because there's very little data for this customer, for this product at all. Sirf ek hi log ne dekha hai, we are going with very blind. So why don't I change it a bit and see if that makes it any different? So I've changed my original matrix and said, okay, customer number 3 also saw this and really liked it, but customer 3 did not like the first product. So customer 3 is exactly opposite to customer number 1. And actually, what the product says to virtually every customer here. And one argument you might have, hold a second, 2 people saw it, they both liked it. So is it something which is universally liked? So that's how you can make a recommender system from here. Good. Take a break or continue? I'll have some discussion and then I will leave you in peace to finish it. Continue? Good. So what I wanted for you guys to try is, we tried a very simple matrix factorization for a small matrix. Right? So I've given you a link for a large matrix which has just got the rating. So let's see if this works. So this essentially is a data which says this particular user for this. Why is this going to be annoying? भैया आपका ये feedback दे रहा है. Okay, ठीक है, अभी चलते हैं, देखते हैं. So this basically has a ratings from each different users for different user items. And you can see there are a large number of user IDs, there are a large number of item ID, and we have ratings. This is a very sparse matrix. Okay, so you might have one user just providing 1 or 2 items in this 10,000 matrix. So one thing which you can then try to read this, convert this into a 2D matrix, and then try to do matrix factorization and see if your code works or not. So that will be your offline assignment. Let's finish some discussion here and then we'll come back to it. So what, and herein I wanted to give you an example. So remember I've said we'll analyze a paper, one of papers which I wrote. Do you have energy to analyze it today, or do you want to do it tomorrow? Sorry? Can't hear. So I said, do you have an energy to go through and listen me talk about a paper which we wrote about price sensitivity, or do you want us to do it tomorrow? Today? Okay, good. So we wanted to ask the question that price is a motivator for customers, right? How do we do that in supermarket settings? So one aspect of the problem was, will a person like a product or not? Other aspect to ask, if I reduce the price of this, will the person like it or not? Or does the price of some products matter? Or if which products matter in a supermarket? Does changing price of everything matters to every customer the same way? No. Which customer matters to what, and how does it go? Okay. So we want to make a price-based recommender system. And here are some punchlines on... Okay, wait a second, guys. This is too noisy for my ear. Okay, this should work. Can still get the sound, right? आपको sound आ रहा है भैया? Good. So before you make a recommender system, you need to ask yourself कि करना क्या? What is the aim of making this recommender system? Do you want to increase sales? Do you want to increase the speed of sales? Do you want a person to be able to buy the product faster? Or do you want to engage with your customer? Do you want to know more about the customer and get him involved with it? That's the first question to ask. The second question to ask is कि data कहाँ है? किस तरह का data है? कितने percentage of end user हमको data provide कर चुके हैं? Okay? या फिर हमको नया data collect करना पड़ेगा? Do we need to create some sort of a loyalty card scheme to collect new data? और अगर करना, या फिर the kind of sugar data which we have given you, basically लोगों को खड़े करो supermarkets में हुआ collecting feedback based questionnaire. Okay? The other question which you have to ask is, are all my products equal? क्योंकि अभी तक हम जो देख रहे थे, हमने हर कॉलम में, अगर हम 4 मूवीज कंसिडर कर रहे थे, all columns meant exactly the same to me. Now, if I'm a movie business, they might mean the same. मतलब सबका एक ही टिकट लगाएंगे हम. But for all businesses, that's not true. कुछ में ज़्यादा प्रोडक्ट मार्जिन होता है, कुछ में कम प्रॉफिट मार्जिन होता है. एंड फाइनल चीज़ ये है कि हम कस्टमर्स को सेगमेंट करने जा रहे हैं. Right? We are going to put customers in different pockets. What is the feature which is similarity feature between them? क्या उनको unite कर रहा है? What is the thing which is common between them? Okay? So हमें इन चीज़ों की जानकारी होनी चाहिए. And once you are at the data stage, you need to collect data. So how are you going to collect them? What kind of data do you have? Do you have customer feedback? Do you have customer ratings? Is it a numerical rating? Is it a qualitative feedback? If it's a qualitative feedback, how do we convert it to a numerical rating? Okay. Then we create our recommender system, but no recommender system is ever perfect. Basically, it's a statistical measure, so you need to keep on iterating it and keep on refining it based on the data which keeps on coming. Okay, so it's not trained once, used many times, but it's a continuous evolution. More so because your customers are not static. वो भी evolve कर रहे हैं time के साथ. The problems with many of these is there is no way to evaluate it. So हमने recommend किया आपको product. हमने एक recommendation matrix बना लिया कि ये customer ये like करेंगे. Unless उन customers के पास हम data ले जा रहे हैं, हमें priori evaluation का कोई तरीका नहीं है हमारे पास. Only when a customer likes or dislikes, he has given me new data, then I know whether my system works or not. But तब तक हमने काफ़ी खर्चा कर दिया है. We have made a whole system, पूरा database के. So we don't know in any way whether this evaluation system is suitable or not. हम customer की बात बार बार कर रहे हैं because customer in movies make sense to all of you, but it could be any kind of recommender system. Okay. The other thing is, how does it scale? हमने 4 प्रोडक्ट का रिकमेंडर सिस्टम बनाया था, हमारी दुकान बढ़ गई और हमारे पास अब 6 प्रोडक्ट हैं। अब जो 2 नए प्रोडक्ट हमने लाए उसके बारे में तो हमारे पास कोई फीडबैक नहीं है पहले से, तो हाउ डज माई सिस्टम स्केल? And the other thing is, if I have made a recommender system for one type of product, can I use data or similar learning or same profile for another type of product? Yes, no? So say I have got a movie-based recommender system, okay? And I am Google, and I also have got the Play Store जहाँ पर हम recommend करते हैं what games for you to download. Can they be related with one another? The girl says no. Does anyone say yes? But it is well known, people who are in the science fiction industry, fiction movies, they like playing fiction-based computer games. Right? Not all people like me who don't like fiction games. Okay. So that's the next question to ask. For every product, do I need to retrain my data? Because training takes a lot of energy. Whole data has to be collected. Okay. So back to our study. We started with a model called shopper model, which tries to mimic what does a shopper do. And it gives a hypothesis. The hypothesis is a bit strange, wherein it says that every customer kind of makes up a product. When you walk into a superstore and you find a product, you create a probability whether I buy it or not. And then you decide that if there's a next product which comes, you compare between these two. And the customer is a bit myopic. He doesn't see the whole store, which is a bit problematic, but it's not the worst of the world. So we start from there. And we caught a customer, and we are going to do matrix factorization. Our matrix factorization was not as straightforward. We did use a deep learning based enhanced matrix factorization. So we had a deep learning layer on one side, we had pure proper matrix factorization on the side, and we added them and then took a sigmoid function to get the output. I'm not going to delve deeper into how we did that, because what is interesting are the results which came out of the study. So look at a large supermarket chain in Germany, which sells a large number of different products, vegetables, meat, eggs, personal care, etc., etc. And looked at their transaction history of 23 months. I'm going to give you a flavor of the amount of data which is there. So the study was led by Dr. Vinay Singh, who works currently for a different firm. And the idea was that we looked at the customers who had purchased products at one or more stores of the supermarket. Okay, so it has a chain. So we first clustered the data set based on the frequency of customers, kitni baar wo aa rahe hain, and we ended up with about 17,800 products for 2,000 customers. So fairly large data set. Okay. And when we grouped them into different groupings or different bar ke different time wo hamare stop mein aaye the, we ended up with roughly 107 different groups, with a total number of transactions being 1.2 million. So we have 1.2 million data spots. And for each transaction, we have what products they have bought and at what price they have bought. This will give us कि अगर price घटा बढ़ा, तो did they start buying more? Okay. So we did the recommender system. We looked at if the price changed, how are they corresponding to price, and overall, this is what the result we got. So herein we are plotting the price sensitivity versus your customer preference. कि हमें ये चीज़ खरीदना है और versus अगर प्राइस कम होता तो खरीदते. किस चीज़ों पर हम ज़्यादा प्राइस सेंसिटिव हैं और कुछ चीज़ों पर we don't care. So you can see there are products जिनमें we have got very high customer preference, and the price sensitivity there is a bit lower. So to explain this further, so look at these products. So these have got high preference but low price sensitivity. Okay. So these are products like bread, milk, salad, butter, vegetables, eggs, newspapers. There's a very interesting thing here. These are the products जो हम वैसे भी खरीदते, right? अगर ब्रेड खरीदना ही है, 5 पैसे किसी दूसरे दुकान में कम मिलेंगे, तो maybe we will not think too much about it. And these are everyday product items. These are also the product items which we buy more. General purchase हम ज़्यादा करते हैं. तो इन पर our data says that there is low price sensitivity. अगर आप price बहुत change भी करोगे तो it doesn't make much of a difference to a customer. Okay. So these are widely purchased products, and if they are necessities for life, price plays a role, but not as much as a role it plays in something else. The next data, so it's all from the same matrix factorization. We have now got the figure. Rather than boring you with the whole detail, I'm just looking at the results now. So here are some other products where we have low preference but high price sensitivity. So these are cheese, canned foods, frozen foods, nuts, paper towels, and that kind of thing. So हम खरीदते हैं इन चीज़ों को, but immediate preference नहीं है. But here I am highly price sensitive. So these are products of convenience. They're not freshly produced. आज नहीं खरीदे कल खरीदेंगे तो भी काम चलेगा. Okay. And they have low preference for customers. There's not immediate need, and there it seems there is high price sensitivity. Then there are products where they have got very high price elasticity because वो सिर्फ यही नहीं और भी जगह मिलते हैं. So look at things like hair care, lip care, baby food, sweets, tobacco, and other things. So इनके साथ क्या है कि there is an alternative availability. अगर आप hair care pharmacy से भी खरीद सकते हैं, convenience store से भी खरीद सकते हैं, supermarket से भी खरीद सकते हैं. So इनमें we figured out people only buy them from a supermarket अगर उनका दाम कम है. Okay? खासकर medicinal product you think कि medical shop में ज़्यादा अच्छा होगा. This used to happen with Horlicks before. I don't know what's the status now. कि Horlicks दवा की दुकान से गिर जाती थी, मेडिसिन है ना. उसके बाद सबको एनर्जी देगी, हमारा दिमाग बढ़ाएगी. दिमाग तो बढ़ा नहीं, पैसे जरूर चलेगा मेरे. Okay. So this was a 3 grouping of products from market point of view. So now we know there are some products on which price matters. There are some products where price could matter, and there are some products where it doesn't matter too much. But now we have looked at broad scale of products. Okay. We also did a bit deeper study and looked at is our data being biased with the volume of purchase which is happening and with customers who buy too much, or are there different price sensitivity for customers who buy too much or customers who buy too little? So in my shop there will be customers who will buy 2 kilos of potato, others will buy half a gram of potato, or not half a gram, a smaller volume of potato. So we then looked at people who did major purchases versus people who did minor purchases. Okay? And then looked at their price sensitivity. So not surprisingly, people who did less purchases, who had less preference for vegetables, say less than 0.5, their price sensitivity was higher than people who did more purchases of vegetables. So जो कम खरीद रहे हैं, उनके लिए प्राइस ज़्यादा मैटर कर रहा है. तो जो ज़्यादा खरीदना तो खरीदने ही वाले हैं. And same thing happens with meat as well, though the numbers are slightly different. The other thing which is different is, if you look at the preference versus the amount of purchases in vegetable section, the number is very oddly placed. So it just goes to show that customers who have high price sensitivity but low preference could be motivated to buy these low preference product. उनको price का sensitive offer दिया जाए तो उनको meat नहीं खरीदना था. Well, not if they are vegetarians, but if they are non-vegetarians and meat नहीं खरीदना था, but उनको preference नहीं था, then we can give them an offer to convince them to buy this product. Okay. It still doesn't tell me about individual products, and this is one the other trick which you can do to showcase. Now this is a data visualization exercise. You can do a heat map of products. So we've done a heat map of 10 random products for some customers. So on bottom we have got customer number. On this side we have various products which can be purchased. And darker the product, the more sensitive that customer is for price there. Now look at products like cucumbers. It's all light here. What does that show to me? I have no price sensitivity, right? अब जो भी करो cucumbers खरीदेंगे ही, या फिर early meal